Hi, welcome to another episode of McClatchy Maths. My name is Natalie McClatchy and today we're going to be talking about calculations of volume and surface area for cones and spheres. As always, you can contact me at mcclatchymaths@yahoo.com or please like and subscribe to the channel or tell me what you think about the video in one of the comments below. Now, this particular video is aimed at Grade 10 and Year 11 General Maths Unit 1. Let's have a quick look at the formulas that we're going to be using in this unit. So we're going to be using these formulas for the surface area of a cone and surface area of a sphere, and also volume of a cone and volume of a sphere. If you're in grade 10, you should check with your teacher to see if you need to memorise the four formulas. But year 11, great news, the QCAA provides this for you on the formula sheet, so you don't need to memorise this for your exams. The main difficulty here that students will face is working out which formula to choose. Now, obviously, the difference between a sphere and a cone is that one is round and the other one is pointy, just like the picture on the right-hand side. But most students will make the common mistake of not picking the right formula because they see that they have to make a calculation of a three-dimensional shape and they'll automatically jump to the volume formulas. Just remember that volume and surface area are two different things. Surface area is calculating the net, basically, or of a three-dimensional shape, whereas volume is calculating the space inside the three-dimensional shape. So you need to make sure you pick the right formula. Now in this video, we're going to go through 7 worked examples. I'm going to be fairly quick with them, so feel free to pause and take notes as you go. I'm going to start with some simple ones. I'm going to move through to some more complex ones. Going to bring in a bit of Pythagoras' theorem, a bit of measurement, a bit of capacity, some conversions of those measurement calculations. So let's get ready with worked example 1, which is simple familiar. Calculate the volume of a sphere with a radius of 0.27 metres. Now for all my examples, I'm going to follow 4 basic steps. The first step is write the formula. So we've chosen the correct formula here, V equals 4/3 pi r cubed. Second step is to substitute the variables that you've been given into the formula. Now in this case, the only variable is the radius, so we're substituting that in 0.27 and it's cubed. Now the next step is to evaluate in stages on your calculator, and the reason why I say to evaluate in stages is that sometimes those in-between stages are allocated half marks. So it's a good idea to do bits in parts. So the part I've chosen to do in parts is 0.27 to the power of 3, and I've represented that by writing that down, and then the last step is to give a final answer. Now I'm not going to stop just there with my third step of evaluation because I haven't been asked to find V, I've been asked to find the volume. So I need to give a statement as my final part of my question. The volume of the sphere is 0.082 metres cubed. Now you might be wondering, how many decimal places should you use? Well, firstly, you should always use the number of decimal places that the question asks you to give your answer in. In this case, we weren't told. So I've chosen to round to 3 decimal places in this case because that first place value after the decimal point was a 0. So it seemed to me to be logical to go with 3. But typically, you would go with 2 decimal places. You would never give your answer with the number of decimal places that are on your calculator, which goes up to 10, because that's quite unwieldy to read. So we always simplify that down to an approximation. Let's look at worked example 2. Now this one is a little bit more complicated. This is volume of a sphere. Topic area, but this time we're actually asked to calculate the radius. We're given the capacity, which is 10 millilitres. So firstly, we're going to write the formula, and then I'm going to convert that 10 millilitres into cubic centimetres. Now, this is the part you need to memorise. 1 millilitre equals 1 centimetre cubed. So therefore, 10 millilitres is going to be 10 centimetres cubed. That's about 2 teaspoons. So it's a pretty small looking sphere. Now I'm going to substitute the information I've got into the formula. Now you notice that this time I don't have the radius, I've got the volume now, which is that 10 centimetres cubed, and that goes on the left-hand side, the 10. So now I'm going to have to do some transposing of my algebra, and this is where people will possibly make some mistakes. You need to be really careful when you're moving things around that you don't make errors. So the first step is going to be that I'm going to divide both sides of the equation by 4/3 pi, because pi is a number. So I'm going to use my calculator and I'm going to evaluate that. I've put that here with 4 decimal places, but it actually has a lot more than that. So I'm going to keep that number fixed on my calculator, and I'm not going to round off early. I need to make sure I do all my rounding at the very end. The answer that I've got now, I'm going to take the cube root of that, and then I'll find that the value of my radius is 1.3365 centimetres. A lot more decimal places than that, but I've written down 4. In my final answer, though, when I write my statement, I'm going to round that down to 2 decimal places, 1.34 centimetres. So that's a little itty-bitty sphere. Now, it's always a good idea to check that your answer makes sense. Thinking back to the question, that sphere had a capacity of 10 millilitres, and I said that's about 2 teaspoons. So it would make sense to have a radius of about a centimetre. It's tiny. Okay, let's look at worked example 3. Now, in this case, I've got to calculate the volume of a cone. So now we've moved on from spheres, we're on to cones, and this one has a diameter of 40 centimetres and a height of 36 centimetres. So let's bring up the formula for volume of a cone. You'll notice that there's no diameter in it, and this is where students will sometimes get tricked. They'll see the number 40 and they'll take that straight away and substitute that in as the radius. So that's a common mistake students will make. Another common mistake they will make is to not show any calculation when they're changing it from a diameter into a radius, and they'll jump straight in and substitute 20 into the formula, potentially losing half a mark. So it's always good to show some of your working on the paper. The radius is the diameter divided by 2, gives you 20 centimetres. Okay, our next step is we're going to substitute that radius into the formula plus the height that we're given. So we've got 2 variables to substitute in this case. So notice that I've written that down in the formula. I haven't started using my calculator yet. My next step is I'm going to start evaluating that in stages. So I'm going to take the 20 and I'm going to square it. That becomes 400. And then I'm going to do the answer in my calculator. And there's a lot of decimal places because we're using pi. So in my final thing, I'm going to write a statement. My final step, the volume of the cone is 15,079.64 centimetres cubed. Okay, so that was a fairly easy question. Once again, just applying the formula. A little bit of complexity there with changing the diameter to a radius. Let's look at worked example 4. Now this one is going to be slightly more complicated again. Total surface area of a sphere. Well, total surface area of a sphere, we've got a radius of 2 centimetres and we have to give this as an exact value. So now we're told how we want our answer presented. Now, pi has an infinite number of decimal places. Your calculator rounds to 10, Excel spreadsheets round to 30. So when we're told to give an exact value, any form of rounding is not going to be exact. It's an approximation. So we're going to leave our final answer with pi, and we're not going to use our calculators at all for this kind of question. So firstly, once again, same step, write the formula. Total surface area is pi r squared. We're going to substitute the value of the radius into the formula. 4 pi times 2 squared. We're going to evaluate this in stages. Well, 4 times 2 squared is 16. And then we've got our final answer. And we're going to leave that as 16 pi centimetres squared. You'll notice there's no decimal places because we're leaving the pi in our final answer. Worked example 5. Now this one here is quite complex. This will be a complex formula question in an exam. Calculate the total surface area of a sphere whose volume is 12 millimetres cubed. So we've got the information about the volume. We need to work backwards to find the radius and then use the radius to find the total surface area. So we're going to do that in stages. Okay, so first of all, we're going to start with the volume and write our formula. We're going to substitute the value of 12 into the formula. We did this before with our little itty bitty sphere. So we're going to work backwards to find the radius, evaluating that in small stages. So now we've divided both sides by 4/3. We're going to divide both sides by pi and take the cube root, and we'll find that the radius is 1.42 millimetres. That's a teeny weeny little sphere. Okay. Now, what's going to be the surface area of this teeny weeny sphere? It's going to be 4 pi r squared. So we're going to substitute in that the radius that we found, 1.42 millimetres, and we're going to square it, multiply it by 4 pi, and we find that the total surface area is 25.34 millimetres squared. Teeny tiny sphere. Okay, next worked example, we're moving on to the surface area of cones now. Now, this one's been drawn for us, which is really nice. Now, in the surface area formula for cones, we've got pi rs plus pi r squared, and we haven't seen this variable s before. It is the sloped side of the cone, so it's something important to be aware of, that we're looking at that sloped side. Now, it's a simple case of substituting into the formula, but I always like to label my diagrams first. So notice I've put on there the radius and the slope side, just to remind me which variable is which. Now, this could be an important skill when you come to composite shapes. For example, you might see an ice cream cone with ice cream on top and then the sphere on the bottom. Always a good idea to label the different parts when you've got those composite shapes. Next, I'm going to substitute into the formula, and this becomes a fairly easy step. And once again, I'm going to evaluate that in stages on my calculator. So I work that out. I've now got the total surface area of that cone is 282.74 centimetres squared. Somewhere else that people will make mistakes here is using the wrong units of measurement at the end. Got to remember that we're actually looking, even though it's a three-dimensional shape, we're finding the surface area of its net. So that's going to be an area, so we give our answer in squares. Whereas when we find volume, we have an answer that's going to be in units cubed. So important distinction there, make sure you use the right units of measurement. Last question. This time we are asked to calculate the total surface area of a cone with a perpendicular height of 1.5 metres and a radius of 30 centimetres. So firstly, I've actually annotated on the cone the new radius. I've changed that into metres. Notice because they're in two different units of measurement, you can't do calculations of volume and surface area if you've got different units of measurement. They've always got to be the same. I could have changed it into centimetres with that height, but I chose to keep the numbers fairly small and simple rather than making them really big numbers. Notice this time, I don't have the slope, and I actually need the slope for my formula. I've got a perpendicular height of the cone instead. That's not really helpful to me, although I do have some skills that I learned back in grade 8, and that is Pythagoras' theorem. I can use that to find the length of the slope side. So I write my formula, c squared equals a squared plus b squared, and then I substitute into the formula the values of 1.5 and 0.3. And then I find the slope s by evaluating this slowly on my calculator, take the square root of 2.34, and I find that the slope side is now 1.5297 metres. Now, it's a good idea to keep that number on your calculator. So use all the decimal places. If you round off at this stage to 1 or 2 decimal places, your final answer is not going to be as close as what it would have been if you'd kept your rounding until the very end. So here is what my cone looks like now. I've got all the sides that I need. Now I can use the total surface area formula. So I'm going to substitute that into the formula. I'm going to evaluate it very slowly on my calculator, writing down my answers as I go. And I come with a final answer of the total surface area of the cone is 1.72 metres squared. So today we've looked at a few different types of examples. I hope that's been really helpful for you, but now all I can think about is ice cream, and I think I'm going to go away and have one myself. So if you've stayed with me and watched all the way to the end, thank you so much for joining us. And why don't you put in the comments your favourite flavour of ice cream? Mine is chocolate peanut butter. Have a lovely day.